Hey everybody, welcome to our video on population growth. This is going to be one of the shorter ones. Yeah, you. Um, so, we're going to talk about how populations grow and change over time. So, one, what happens to populations as they grow? Two, how does one population size impact other organisms? So, that's where we're going to talk about predator prey relationships because when organisms grow, when their populations grow, they have massive impacts on everything else. And we'll take a small look at that. So, here in the middle, we have exponential growth on the left, logistical growth on the right. These are both ways that animals increase in size, or their populations do. So, exponential growth is exactly what I want to happen in my bank account. It's unimpeded growth. Like if we arrived on a planet and it had just massive amounts of food, water, and shelter, then our population would grow like crazy. Humans are currently in exponential growth. We're starting to see it slow a little bit, but we are in exponential growth right now on this planet. But as we know, every environment has carrying capacity. That's where logistical growth comes in. So what we see is the populations increase and then they level out. They hit their carrying capacity, which for this graph over here, it's right about there. And if you remember correctly from the previous video, it was K. The letter K is carrying capacity. So we see that a population hits its carrying capacity and levels out. That's called a logistical growth. And that's usually what happens. Now, the graph gets a little bit more intricate than this, and that's what we're going to look about here in a second. But this is how populations usually start and grow. Okay, so it's exponential versus logistical growth. Now, down here, we're going to take a look at this. We're going to look at predator-prey relationships. So we're going to start with a family of rabbits. Okay, rabbits get to a new field, let's say, and they go crazy. Their populations increase a lot because there's food, there's water, there's shelter. But what happens is their buddy the fox is right there too. So as the rabbit population grows, so does the fox population. Well, when the fox population increases, more rabbits are eaten. So we see a dip in the rabbit population. Well, if there's fewer rabbits now, the foxes aren't eating as well. So their population is going to start to dip down too. Oh, well, now there's less foxes, so more rabbits can live. Oh, there's more rabbits now, more food for the foxes. So they're going to see a bump up as well. Oh no, now we have more foxes. Rabbits are going to go down. And then foxes, the rabbit population goes down, so the fox population. So we start to see this little zigzag of a graph. And we see when one population increases, so does the predators that eat it. And then as soon as, like, in the Yellowstone National Park, when they release those wolves, what do you think happens to the deer? Kind of thing. So hint, hint on that. But that's a predator-prey relationship, is we see this logistical growth, and then carrying capacity for both these is right about there. Usually the predators are a little bit lower in numbers than the prey. And if you think back to one of the previous videos where we talked about energy transfers through the trophic pyramid, you'll know why. Because less energy through the pyramid. Okay? But that's a predator-prey relationship. So if you want to think back to up here, if we had rabbits going through exponential growth, we would also have foxes going through exponential growth. If we had rabbits going through exponential growth, what do you think happens to the grass? All the grass is going to die. So that's why logistical growth is more realistic and more necessary because it creates this limit. Well, I hope that helps and good luck.